Hello. Today I would like to talk about count good nodes in binary tree. So let's dive right in. Within a binary tree, a node X is considered good if the path from the root of the tree to the node X contains no nodes with a value greater than the value of node X. So example 1. In this path, how about root node? Root node is root from the root to the this node. This node is current node X, and this is 2, and max no max value so far is 2. So it means this is greater than X. So no nodes within a value greater than the value of node X. So this node is good. How about this? Now, 1 is current node and max value from the root to this node is 2. So max is 2. So this current node is less than max value so far. So this node is not good. Next, 3 is current node and the max value is 2. So current node is greater than max node. So this node is great. Okay, next pass. Next pass is this. Root node is good because root node is 2 and the current node is also 2. So no node is greater than the value of X. So this node is good. How about this? This is the same condition of this. So this node is not good. And now this path maximum value is root node value 2. How about this current node? This value is 1. So this value is less than maximum value 2. So this node is also no good. Okay, next path. How about this root? Of course, root node is good value. This node is not good. And last, this node is current value. And the maximum value so far is 2. So current value is greater than maximum value. Oh, sorry. I forgot to start stopwatch. So let's start. Hmm. Okay. Before learning algorithm, before try to solve problem, and keep in mind it. Let me organize the expression of greater and less. This expression is essential. So if A is greater greater than x. This means mm, this. And a is less than x is this. And a is greater than and greater than or equal to x. This. And less a is less than or equal to x is this. And we also express this is a is at least x. And this a is at most x. Mm. This is very important. And in this question, no node with a value greater than the value of node x. How about this? This means no node greater than x. No node greater than x. So a is greater than x is this. But no node is greater than x means x is less than nothing. So this means x is greater than every node. A lot of guide told me that it's a good practice to ask your interviewer to ensure you understood the problem correctly. I need to make sure I don't forget it either. So let's check the problem sentence. Let's ask to interviewer. Okay. Uh, we traversed uh, we traversed from the root to the current node. The current node is here. Current node is next here. So we traversed from the root to the current node. So our root is here and here. Go back to root and here and here. Go back here. Okay, do you remember? We can use DFS, depth first search. This problem's key point is the current node is good if maximum node value so far. Maximum node value so far is in this path root node second. So current node is good if maximum node value so far in the past is less or equal to the current one. So x, まあ、current value is greater than うん max so far in the past. うん When we use DFS, we have to define the recursive function and assume that recursive function is going to return the result. In this case, maybe the number of good nodes. So let's jumping code. We define recursive function and pass the node, current node and the maximum mm, maximum value so far. And uh, we have to think about uh, edge case if node if node is empty, its current node is empty, return 0. In this function, we have to return the number of good nodes. Then we verify if the current node is good. Mm, if it is good, result is 1. Otherwise is 0. So if node value if node value greater than max so far, less equal 1, else less equal 0. Is it correct? Node dot value, this is current value, is greater than maximum value so far in the past. In this condition, less equal 1. Anything else otherwise, less equal 0. Maybe okay. We need to next action is updating the max value so far. So max value so far is max uh, node value or max so far. And then, and that's where DFS mainly point. We pass the next node. We pass the next node. So it's called left child and right child. Node left and max value is we already updating, so we pass it and we have to write, not write. And mm, this is the left child subtree's total total counts of good nodes. So we have to add, so count up less. Yeah, maybe okay. Mm, and DFS function return less. And finally, uh, we have to call DFS function. And the first node is root node. And um, the max value, uh, the max value is root value. So maybe that's it. And last, let me check time complexity and the space complexity. Time complexity is we traverse every node because we use DFS. So time complexity is linear time, and space complexity is uh, we used DFS, so we have to recursive function, and it means it means the height. We call DFS function the number of core DFS function is height. So O H H means height. Hmm. Let's check this answer. Yes, that's correct. Okay. Thank you for watching. See you by next time. Bye bye.